All right, guys, we're going to do logarithms, chapter 8.3. Now, this is very, very easy. Looking at, we've already dealt with stuff with exponents in exponential form. Okay, logarithms is just another way of writing something in exponential form. Okay, for example, if I asked you what is the decimal of 3/4, you would tell me 0.75. Okay, just a different way of writing the same thing. That is what logarithms are for. Are really. Okay, so if I had 3 squared equals 9, this is what we call exponential form. It has the base, the exponent, our answer. If I asked you to put it in logarithmic form, you would put log. My base is 3, my answer is 9, and my exponent is 2. So when we put it in logarithmic form, the exponent goes on the outside, base is on the bottom, 9's my answer. Okay? Now the first set of problems that the book is going to ask you to do is to change it from logarithmic form to exponential form and vice versa. So for example number 1, it's in log form. So we're going to change it to exponential form. What is my base? It is 2. What is my exponent? 3 equals 8. There's my answer. Okay? For B, same thing. What is my base? It's 4. What's my exponent? -4. What's my answer? 1/256, which is a true statement because 4 to the -4th is 1/256. Different way of writing it. Now, for example 2, I gave you exponential form. We're going to put it in logarithmic form. So first thing I'm going to do is write log. What's my base? 4. What's my exponent? 2. What's my answer? 1/2. And that's it. That's all that we got to do. Okay, that's just converting it from log form to exponential form and vice versa. Okay, with example 3 is telling you to evaluate. That means we're going to get an actual number answer. All right, first thing you notice is that this is almost in log form, but it's missing the equals. So we're looking for this right here. And this, we already learned, is the exponent. Stands for the exponent in logarithmic form. So the only way that we know how to work these problems is to put it back in exponential form. Now, what do I mean by that? What's my base? 16. What's my answer? What's my exponent? X. What's my answer? 4. Okay, so step number 1, exponential form. Okay, step number 2, we're going to get the same base, just like we did on chapter 8.2. So what's the same base of 16 and 4? Well, they can both have a base of 4. How can I rewrite 16 to have a base of 4? 4 squared. Now, what is 4's exponent? It's not there, but it's understood to be a 1. Now, we simply, step number 3, solve for x. Okay, so I multiply my exponent in my power. 4 to the 2x equals 4 to the 1. So 2x equals 1. So x equals 1/2. There's my answer. Okay, which makes sense. 16 to the 1/2 is really the square root of 16, which gives me 4. Let's look at B. First thing I'm going to do, set it equal, make an equation. All right, then we're going to put it in exponential form. What's my base? 3. What's my exponent? X. What's my answer? 81. Now, step number 2, same base. So I have 3 to the x equals 81 can be rewritten 3 to the 4th. Same base, drop them, x equals 4. Okay? Last one, equals x. Okay? What is my base? 1/2. What's my exponent? X equals 256. All right. Now, this one's a little tricky. So the first thing that I want to do is I'm going to bring, well, 1/2 to the top. So I'm going to get the reciprocal. So this is really 2 to the negative 1. X equals, now rewrite 256, it's going to be 2 to the 8th. So now I have 2 to the negative x equals 2 to the 8th. I multiplied negative 1 times x. Okay, so then my bases drop. I have negative x equals 8. So x equals negative 8. Okay, let me go back and explain this one more time. I have 1/2 to the x. Well, 1/2 is really 2 to the negative 1 because I needed the 2 to come up. And remember, anytime we bring something from the denominator to the numerator or vice versa, the exponent sign changes. And that's how I got 2 to the negative 1. Okay, here it is. If you have any questions, I'll be answering questions later, and you can email me. Thank you. Bye-bye.